friends, welcome to our Grade 8 Mathematics Student Support Program. We have devised a series of revision videos for you. We have selected some topics where usually students have problems. So let us start. Our first revision video is on the chapter HCF of algebraic terms and factorization of algebraic expressions. So we are going to start with a recap of what is meant by HCF, followed by HCF of algebraic terms, and then we shall have a look at what is meant by factorization. We will consider factorization of two terms, factorization of compound factors, and finally factorization of four terms. So let us start. HCF, as you already know, is the highest common factor. Let us have a look at the first example. Find the HCF of 12 and 20. So we're going to use the method of prime factorization. 12 can be written as 2 times 2 times 3, that is in terms of prime numbers. 20 can be written as 2 times 2 and times 5. So what are the common factors? We can see that 2 is common. 2 is again common. So the HCF is going to be 2 times 2, which is 4. We now consider the second method, that is using index 4. Find the HCF of 18 and 20. So 18 can be written as 2 to the power of 1 times 3 to the power of 2. 20 can be written as 2 to the power of 2 times 5. Now, we can see that the least power of 2 is 1. You have 2 to the power of 1, 2 to the power of 2. The smaller one is 2 to the power of 1. So the HCF is going to be simply 2 to the power of 1, which is 2. Remember, for HCF, we consider only the common factors. So here, 3 is not common and 5 is not common. We now move on to HCF of algebraic terms. So the first example, find the HCF of PQ and P square Q. We use the method of expanded form. So PQ can be written as P times Q. P square Q can be written as P times Q. So the HCF will be P and Q. We can see that P and Q are common. So the HCF will be P times Q, which is PQ. A second example, find the HCF of PQ and P square Q to the power of 3. So here we are going to use the method of index form. PQ is simply P to the power of 1 times Q to the power of 1. P square Q cube is P to the power of 2 times Q to the power of 3. So the least power of P is 1. Here you have P to the power of 2, P to the power of 1. So P to the power of 1 will be the common factor. And the least power of Q is 1. So the HCF is going to be P to the power of 1 times Q to the power of 1, which is PQ. We now move on to a third example. Find the HCF of 18xy cubed and 24x squared y squared. So here we use the method of expanded form. 18xy cubed can be written as 2 times 3 times 3 times x times y times y times y. 24x squared y squared can be written as 2 times 2 times 2 times 3 times x times y and times y. So let us look at the common factors. 2 is common, 3 is common, x, and then we have y and y. So the HCF is going to be 2 times 3 times x times y, which gives us 6xy squared. We now move on to a fourth example. Find the HCF of 2p q squared r squared, 6p cubed q r squared, and 15p squared q r cubed. So here we can write 2p q squared r squared as 2 to the power of 1 times p to the power of 1 times q to the power of 2 times r to the power of 2. The next term, 6p cubed qr squared, can be written as 2 to the power of 1 times 3 to the power of 1 times p to the power of 3 times q to the power of 1 times r squared. 15p squared qr cubed can be written as 3 power 1 times 5 power 1 times p to the power of 2 times q to the power of 1 times r to the power of 3. So the HCF is going to be simply p to the power of 1 times q to the power of 1 times r to the power of 2. You can see here that 2 is not common. 3 as well is not common. 5 also is not common. And the smallest power here for p is 1. The smallest power for q is 1. And the smallest power for r is 2. So the HCF is simply pqr squared. We have included some revision exercises for you to practice. So here are these questions on HCF of algebraic terms. We now move on to factorization of algebraic terms. So in grade 7, if you remember, we have learned how to expand. So we were doing 3 into x plus y. We were expanding and writing it as 3x plus 3y. So now we are going to do the reverse, that is, we are going to factorize. So let us consider some examples. The first one, factorize 2a plus 2b. So I'm going to explain a simpler method. 2a can be written as 2 times a. 2b can be written as 2 times b. So here the HCF is 2. This 2 is common to both terms. And I'm going to write the 2 here. You can see 2. The HCF is 2. So 2 is common here. And for the first term, we are left with a. For the second term, we are left with b. So we have plus b. Because I have a plus here, I keep the plus. Second example, xy plus 4x. So xy can be written as x times y. 4x can be written as 4 times x. So what is common to both terms is x. So here x is common to both terms. I have x here. Now, for the first term, y is left. So here is y. Because I have plus, I need to keep the plus. And for the second term, 4 is left. So here is the 4. So xy plus 4x can be factorized as x into y plus 4. Third example, 3x plus x squared. So 3x can be written as 3 times x. X squared is written as x times x. So what is common here is x. So again, I have x common. So for the first term, 3 is left. Because I have a plus, I keep the plus. For the second term, x is left. So 3x plus x squared can be factorized as x into 3 plus x. We now move on to a fourth example where we have minus. So 5a minus ab. We use the same method. 5a is 5 times a. ab can be written as a times b. So you can see that a is common. So because a is common, I write a here into. Now be careful, you have a minus, so that's why I have already put the minus. For the first term, 5 is left. So here is 5. For the second term, b is left. So you have b. In other words, 5a minus ab can be factorized as a into 5 minus b. Next example, xz minus xyz. So xz can be written as x times z. xyz can be written as x times y times z. So what is common here is x and then z. Now, for the first term, both x and z are common. So xz. What will be left here? Be careful, it is not 0. It is going to be 1. So for the first term, because xz is common, I'm left with 1. And again, be careful of the minus sign. So I have already included the minus sign here. Now you have 1 minus y, which is left. One way of checking whether your answer is correct is by expanding it. If I expand, I should get the same thing here. So xz times 1 is xz. xz times minus y gives me minus xyz. Next example, 6x minus 2x squared. So 6x can be written as 2 times 3 times x. 2x squared can be written as 2 times x times x. We can see here that 2 is common and x also is common. So I'm going to take 2x as common factor. So again I have a minus. For the first term, 3 is left. And for the second term, x is left. So 6x minus 2x squared can be written as 2x into 3 minus x. Now we have minus in front of the first term here. Minus 2m minus 2n. When I'm going to find the factors, I won't take the negative sign into consideration. So I'm going to consider 2m and 2n only. So 2m is 2 times m and 2n is 2 times n. So 2 is common here. Now, be careful. You have a minus here. You have a minus here. So I take the minus outside as well as the 2. So I have minus 2 as common factor. Now, because I have taken the minus outside, I need to be careful. Inside the bracket, the sign will change. Minus times plus will give me the minus which we have here. So this sign is going to change. You need to be very careful here. So for the first term, 2m, I have 2 common, so I'm left with m. For the second term, I have n, which is left. So minus 2m minus 2n. When I factorize, I get minus 2 into m plus n. We now consider another example dealing with a negative sign. So minus 3mn minus 2m. Again, I'm not going to consider the minus. I'm just going to consider 3mn, which is written as 3 times m times n in expanded form. So 2m is written as 2 times m. So here m is common. Now, remember minus is common in both terms. So I'm going to consider the minus as a common factor. So minus m. Now again, because I have taken minus outside, the sign inside the bracket will change. Remember, you have learned in grade 7 that a negative number times a positive number will give me a negative number. So here I'm going to have 3n plus 2. So minus 3mn minus 2m, when factorized, will give me minus m into 3n plus 2. Another example, minus x plus 2x squared. So here I have plus between the terms. So minus x plus 2x squared, I'm going to write x simply as x. 2x squared can be written as 2 times x times x. So the common factor here is x. I take minus x outside. So again, because I have taken minus outside, the sign inside the bracket will change. So I had plus, now it's going to become minus. So for the first term x, I have already taken x common. So again, it is not going to be 0, which is left, but 1. Why? Because 1 times x gives me x, whereas 0 times x will give me 0. So here I'm going to have 1 minus 2x. So minus x plus 2x squared when factorized will give me minus x into 1 minus 2x. Remember, I said earlier that you can check your answer by expanding it again. So minus x times 1 will give me minus x. Minus x times minus 2x will give me 2x squared. We now move on to some exercises for you to practice. Now, let us consider factorization of compound factors. So the first one, 3 into a plus b plus x into a plus b. So you can see here that a plus b is common. So when I'm going to factorize, I'm going to have a plus b, which is common here. And what is left is 3 plus x. So here it is, 3 plus x. Second example, a into x minus 2 plus b into x minus 2. So here you can see that x minus 2 is common to both terms. So I take x minus 2 common and I'm left with a plus b. So I have x minus 2 into a plus b. Third example, m into 3 minus k minus 2 into 3 minus k. So here I have a minus. And 3 minus k is common. So 3 minus k is going to be taken outside. And I'm left with m minus 2. Now we move on to factorization by grouping. What is meant by factorization by grouping is I'm going to consider the first type of factorization which we had done, as well as factorization of compound factors. So let us look at the first example. xy plus xz plus 2y plus 2z. So here I'm going to group the first two terms together and the last two terms together. So I have xy plus xz plus 2y plus 2z. You can see here that x is common for the first pair of brackets and 2 is common for the second pair of brackets. So let us consider the first one. X is common, so I'm going to have x into y plus z. Now for the second pair of brackets, 2 is common and I'm going to have 2 into y plus z. So now look at this line. You can see that y plus z is common to both terms. So I take y plus z outside and I'm left with x plus 2. So you can see that we have used factorization of two terms as well as factorization of compound factors to factorize what we call 4 terms. A second example, AP plus 5P plus AM plus 5M. So again, I'm going to consider the first two terms and the last two terms together. So first two terms, I have AP plus 5P and I can see that P is common. So I take P outside and I'm left with A plus 5. The last two terms now, I can see that m is common. So I take m outside and I'm left with a plus 5. Now looking at this line, we can see that a plus 5 is common to both terms. So I take a plus 5 outside and I'm left with p plus m. We now move on to a third example where we will have minus. So mn plus ny minus 3m minus 3y. I'm going to consider the first two terms together and the last two terms together. However, because of this minus sign, I need to be very careful. So let us see what we do. mn plus ny will be between the first pair of brackets. Now I'm taking minus outside. So what happens is the sign inside the bracket will change. I had a minus, so now this is going to become plus. You need to be very careful here. Students very often forget to change the sign. So for the first pair of brackets, n is common. So I have n into m plus y. Minus, for the second pair of bracket, 3 is common. So I have 3 into m plus y. And you can see that m plus y is common to both terms. So I have m plus y into n minus 3. Again, you can check your answer by expanding. So you can check by expanding, that is m times n, m times minus 3, y times n, y times minus 3. And you'll get the expression which was given at the beginning. A fourth example, 4p minus 4q minus pr plus qr. So I'm going to consider the first two terms together and the last two terms together. So again, I have a minus which separate the second and third term. So I need to be careful. The first two terms will be 4p minus 4q minus, now for the second bracket, I have pr minus qr. For the first pair of brackets, I have 4 common. So I have 4 into p minus q minus, for the second pair of bracket, I have r common. So I have r into p minus q. And I can see that p minus q is common. So I'm going to have p minus q into 4 minus r. Next example, a plus b minus ac minus bc. So I take the first two terms together and the last two terms together. Now, look at the first pair of terms, a plus b. Do we have anything common between these two terms, a and b? No, there is nothing common except 1. So I'm going to take 1 as a factor. Okay, minus AC plus BC. So here again, the sign is changing because of a minus in front of a bracket. So I have 1 into A plus B minus, for the second pair of brackets, we have C common, so we have A plus B inside. And A plus B is common to both terms. So we have A plus B into 1 minus C. Another example, x squared plus yz plus xz plus xy. So this one is slightly different. Let us have a look. If I group the first two terms and the last two terms as we have done for the previous examples, what do we observe? Is there anything common between the first two terms? No. So what I'm going to do is, I'm going to interchange the second and third term. Why? Because there is no common factor for the first two terms. As you can see, x squared plus yz, there is nothing common between these two terms. So I'm going to swap. I'm going to interchange the place of the second and third term. So I have x squared plus xz plus yz plus xy. So let us have a look at the first pair of brackets. What is common between these two terms? X is common and I'm left with x plus z. Now the second pair of brackets, y is common and I'm left with z plus x. Now x plus z and z plus x are same. Remember 2 plus 3 is same as 3 plus 2. So I can write it as x plus z into x plus y. Now another example with minus here. So I have 24mn minus ab minus 3an plus 8bm. If I consider the first two terms and the last two terms together, so I can see that for the first two terms, there is nothing common. 24mn minus ab, no common factor. For the second pair of terms, 3an plus 8bm, nothing is common again. So what are we going to do? We are going to interchange the second term and the third term. So I have 24mn minus 3an minus ab plus 8bm. You need to be careful when you're interchanging the terms. You need to carry the sign as well. So here, first pair of brackets, I'm going to have 24mn minus 3an. Now minus is going to be outside for the second pair of brackets. So the sign inside the bracket will change. So I have AB minus 8BM. Now for the first pair of brackets, 3N is common and I have 8M minus A inside. For the second pair of brackets, B is common and I have A minus 8M. So what do you notice here? For the first one, I have 8m minus a. For the second one, I have a minus 8m. And these two are not equal. However, I can rewrite a minus 8m as negative outside into 8m minus a. So if I expand, I'm going to get minus 8m plus a, which is same as a minus 8m. So I'm going to take this minus with a minus b. I'm going to have plus b. And this can be written, the second bracket now can be written as 8m minus a. So 8m minus a is common to both terms. And I'm left with 3n plus b. You can see that this example is slightly more difficult because we didn't have common factors initially, and then when we started factorizing, we did not have the same sign. So we had to do some minor modifications here. Now, these are some exercises for you to practice. I would advise you to revise by first doing the exercises which are found in the textbook. Then you can also practice using the exercises which were found in the video on this topic. And you also do these additional questions. You also have some links where you can get additional exercises for you to practice, as well as some additional explanations on how to factorize. So students, we are going to end the first video regarding revision on the topic HCF of algebraic terms and factorization of algebraic expressions. I hope you're going to practice these exercises, which would help you for your exams. Thank you.